Good afternoon. I am Mona Rubai. I am PhD student at Cardiff University in the United Kingdom. I'm going to present my study, which entitled as Influence of Composition Variations on the Fracture Behavior of Self-Combating Concrete.
Just point them later.
Oh, sorry.
Sorry.
At the outline, I'll start with the definition and requirements of self-compacting concrete. Then I'll give a brief idea about two properties of fracture energy. The first one is size-independent fracture energy, and the second one is stress crack opening relationship. After that, I'll present the scope of the study. Then I'll present the results and highlight the main conclusion. Self-compacting concrete is a highly flowable non-segregation concrete that can separate it in two places, fill the formwork and under its own weight without any mechanical consolidation. And this type of concrete can be used in reinforced concrete structures, especially in where there is congested reinforcement, and especially when the complicated structural design. Requirements of self-compacting concrete. There are three requirements. The first one is filling ability, passing ability, and stability. Filling ability is the ability to flow and totally fill the formwork. Passing ability is the ability to pass in confined section without blocking. And stability is the ability to stay homogeneous during and after casting process. As I mentioned before, that I will talk about the main properties of fracture energy. The first one is the size-independent fracture energy. According to Rylam recommendations, the specific fracture energy can be obtained by the work of a fracture requiring based on notched three-point bend, and by using this equation, the obtained specific fracture energy is dependent on size and specimen size. After that, Whitman and Whitman are proposed the methodology that the name is boundary effect hypothesis to get or to obtain size independent fracture energy. Depend on different sizes of specimens and different notches. After that, Carihalo et al. Simplify this method by using to get non-size independent fracture energy to obtain by testing just single size specimen and only two notches, shallow and deep notches. Besides size independent fracture energy, there are another property which is stress crack opening, and by using non-linear hinge model and by using an inverse procedure, this relationship can be obtained, and lots of information about this procedure can be obtained in this reference here. Scope of this study: there are three self-compacting concrete, 30, 60, and 80 megapascal, and these mixes are differing by coarse aggregate volume fraction. There are three volume fraction of coarse aggregate. There are three paste to solid ratios, and definitely because there are three grades of strain, 30, 60, 80. Also there are three water to binder ratio. depending on the grade of the strength. Then the fracture behavior parameters, as I mentioned before, size independent fracture energy by using 3-point bend test, and the stress crack opening relationship by using nonlinear hinge model are obtained. Results. Firstly, the load deflection diagrams for different SCC mixes for both 2-notch shallow and deep notch are shown in this figure here. These figures show the top figures show the effect of volume of fraction on GF. It is seen from this figure that GF is increases as the volume fraction of coarse aggregate is increasing, and this increases is less pronounced with the SCC with mix 80 megapascal in comparison with the 30 and 60 megapascal. Regarding the effect of water to cementitious material on GF, it can be seen, or as expected, the GF is decreases as the water to binder increases. And the effect of the third parameter that in this study, there is the effect of best to solid on GF. It can be seen that the best to solid has, there is a slight increase in the compressive strength when the best to solid increase, but there noticeable decrease in the GF when best to solid is increased. Then, as I mentioned before, that when using a non-linear hinge model, and the expression of CMOD and the central load, they are used to minimize the difference between experimental load CMOD and theoretical predicted. And by this, the results of this minimization as shown in these figures here. After that, by using this minimization, the parameters of stress crack opening relationship can be obtained for grade 30, 60, and 80, and it can be seen from these figures, all these figures, that the crack opening is increased with the increasing of the volume fraction of coarse aggregate. As for the direct tensile strength of concrete, it is known that direct tensile strength is 2/3 of indirect tensile strength, and direct tensile strength here is can be found by using an inverse procedure, and indirect tensile strength can be used by the can found by test the splitting tensile strength of concrete, and from these figures, by use these figures or the ratio of direct to indirect strength is shown that dominated by the coarse aggregate volume fraction, and the final parameter is the characteristic length, which gives an indication of the ductility of concrete mix or self-compacting concrete mix, also dominated by the volume fraction of coarse aggregate. So maybe there is no time to read the...
11 minutes and so.
Okay. This is the main conclusion. That can I read it or continue? Okay. Specific fracture energy is increased with the coarse aggregate volume fraction, and this GF decrease with the increase of water to cementitious material, and best to solid ratio also with increased best to solid ratio, the GF decrease. Critical crack opening is also dominated by the coarse aggregate volume fraction, and the same thing with the characteristics. Thank you very much.